Good morning, students. Let us continue our discussion of chapter 9, Ray Optics and Optical Instrument. Now today we are going to discuss lens formula. Now lens formula you can define for concave lens, you can define for convex lens. You can define for convex lens with real image, you can define convex lens for virtual image, and also you can define concave lens for virtual image. Here what we'll do, we'll consider convex lens and we'll try to define lens formula for real image. Now you see, this is your convex lens and AB is an object. A ray moves parallel to the principal axis and after refraction it passes through the focus. Now another ray passes through the optical center of the convex lens and after refraction it goes undeviated. Now these two refracted rays, when intersect, at the intersecting point you will get an image A dash B dash. The image is real and inverted. Now we'll try to define lens formula considering this real image for the convex lens. Now if you consider two triangle ABO, A dash B dash O, then these two triangles are similar and as a result the sides are proportion. So AB by A dash B dash equal to OA by OA dash. Now again for the triangle COF and B dash A dash F, these two triangles are similar, so again the sides are proportion. So OC by A dash B dash equal to OF by F A dash. Okay, now CO or OC is same as AB, so you can simplify this expression by substituting OC equal to AB. So AB by A dash B dash equal to OF. Now F A dash, you see it is nothing but the difference between OA dash minus OF. So OA dash minus OF, if you see the diagram. Now 1 and 2 you can equate as AB by A dash B dash and AB by A dash B dash is there. So you can consider OA by OA dash equal to OF by OA dash minus OF. Now you see OA is your object distance, so it is your minus U because the measurement is from the optical center and it is opposite to the direction of the incident ray. So OA is your minus U and OA dash is your V because it is along the direction of the incident ray. Always in lens we used to measure the distance from the optical center O. So and OF is your focus or focal length and OA dash again is your V and OF is your F, so it is your V minus F. So the convention part is what? If you moves from optical center along the direction of the incident ray, then it is positive, otherwise it is negative. So if you substitute this one, minus U by V equal to F by V minus F, and simplify by cross multiplication, minus U V minus F VF, so minus UV plus UF equal to VF. So you have to divide this expression throughout by UVF. So if you divide this expression by UVF, then it's your minus 1 by F plus 1 by V equal to 1 by U. So if you change the parameter with respect to the equal sign, then it becomes easier 1 by V minus 1 by U equal to 1 by F. So this is your lens formula, and we are trying to define the lens formula by considering convex lens forming real image. So it is same geometry, but you try in home for convex lens producing virtual image as well as concave lens producing virtual image. Now let me try to define the magnification for the image. So number 3, the ratio of the size of the image to the size of the object is called linear magnification. So that is M equal to HI by HO. So HI is your size of the image, I is for image, and O is for object, so HO is the size of the object. Now from 1 you see AB is your height of the object, so you can consider size, that is H0, HO, and A dash B dash, as it is in negative y axis, that's why minus sign is there, and it is your OA is your minus U, and OA dash is your V. So if you simplify, HI by H0 equal to V by U. So HI by H0 is nothing but is your M, so M is equal to V by U. So this is the linear magnification for the real image formed by the convex lens. You try for virtual image formed by the convex lens as well as virtual image formed by the concave lens. You try by yourself. This is simple. You will get these things in any reference book or in the textbook itself. So I am not doing that part. You try by yourself. That's a very simple one. I am leaving on you. Now next topic which we are going to define, the power of a lens. So almost all of you know the ability of a lens to converge or diverge light after refraction is expressed as power of lens. If the lens has a higher ability to converge or diverge, converge in case of convex lens and diverge in case of concave lens, then it has more power. So if F be the focal length of a lens in meter, then power of the lens is your P equal to 1 by F. This expression we are going to use. So SI unit of power is your diopter. Means convergence is possible or divergence is possible high if the focal length is less. So that's why P equal to 1 by F. So F is always in meter. If you want to express this equation, or if you want to use this equation in numerical, P equal to 1 by F, always convert focus in meter. Then you use this formula. Now the next topic which we are going to define is your thin lenses in contact. So here we are considering two convex lens in contact. Now you see both the lenses have different focal length F1 and F2. So O is the object, so a ray moves and strikes at the midpoint of the convex lens of focal length F1. Here basically the lens is very thin, that's why we are considering the refraction occurs at the midpoint rather than at the interface, because the lens is very thin. So you can consider a same point if it is at the center or if it is at the edge. So at the center the refraction occurs, the change in direction occur, and again on the lens of focal length F2 further change in direction occur. So if you extend the change in direction for the lens of focal length F1, then you will get the dotted extension, and the dotted extension is nothing but the image. The dotted extension which intersects on the principal axis is nothing but the image formed by the lens of focal length F1, and the solid refracted ray formed by the lens of focal length F2 is nothing but the final image. So here U is the object distance, and image found by the lens of focal length F1 is your V1, and image found by the lens of focal length F2 is your V, and we are measuring from the optical center the distance. Now if we consider the lens of focal length F1, so U is the object and V1 is the image, because the refracted ray, if you extend it, meets at the point on the principal axis which is at a distance of V1 from the optical center O1. So 1 by V1 minus 1 by U equal to 1 by F1. Now if you consider the lens of focal length F2, then V1 distance is nothing but the object distance, virtual object distance you can say, and V is the final image. So 1 by V minus 1 by V1 equal to 1 by F2. So if you add 1 and 2, you will get 1 by F1 plus 1 by F2 equal to 1 by V1 minus 1 by U plus 1 by V minus 1 by V1. So 1 by V1 minus 1 by V1 goes off, so you do have 1 by V minus 1 by U. So you see V is the final image of the combination and U is the object. So if you consider F is the focal length of the combined system, then it is your 1 by F. So you can say that if two lenses of focal length F1 F2, then 1 by F equal to 1 by f1 plus 1 by f2 provided f is the focal length of the combination. Now similarly you can express the power as we have defined p equal to 1 by f. So you can say that p1 plus p2 equal to p, and p is the power of the combination. So please go through this part and try to understand. Let me show you the diagram, and let me show you the diagram. This diagram part is very important, and the geometry part also. If you have any doubt, please put your doubt. And this is the lens formula for the convex lens producing a real image, and real is always inverted and virtual is always erect. So let me to redefine more prominently. This is your final image I, you can say, and this is your image I1. So I1 is the image formed by the lens of focal length f1, because we have extended this ray, and this ray is nothing but the part of this one. And now further refraction occurs at this point and it converges at I. So please go through this topic. These topics are very important, and try to go for the revised syllabus, and try to go for the lens formula for concave lens forming virtual image and convex lens forming virtual image, and also corresponding their magnification. Thank you.